We will solve this today's LeetCode problem. This is LeetCode medium 1. Let's see what it is. So here we have given number of steps to reduce a number in binary representation to 1, right? Given the binary representation of an integer such that a string s is given and return the number of steps to reduce to 1 under the following rules. Okay. So if the current number is even, you have to divide it by 2, and if the current number is odd, you have to add 1 to it. So okay, so we need to apply operations on this string on this string which is a binary representation of a number, which is a binary representation of a number, to make it 1, right? We need to apply some operations here on this string to make it 1, right? So here we have, if you see example 1101, if you see here 1101, this number represents what? This represents number 13, right? This represents number 13. So here we have seen that if the current number is even, you have to divide by 2, but if it is odd, you have to add 1, right? So it is an odd number, right? So it is the odd number. It means I need to add 1. If I add 1, what it does, it become, it becomes 40, which is this 111, right? This is 111. Okay, sorry, this is 111, right? This is 40. So the first operation is here by adding it. Now it is telling that if the number is, sorry, this should be 10, right? If the number is even, we need to divide it by 2. We need to divide it by 2. It means it becomes 7. It becomes 7. It means one bit will left shift, right shift by 1 bit, right? This becomes 7. This is again odd, so I need to add 1 again. If I add 1 again, so if you know binary representation, if you add 1 again here, it means this 1 will becomes 1110. So here it becomes 0. Here it becomes 0, right? Okay, let's forget for now. If we add 1, this become 8. So this becomes 8, right? This becomes 8 again. It is an even, so we will divide it. It become 4 again. It is an even, we will again divide it, so it becomes 2. And if we again divide it, it becomes 1, which we really wanted, right? So if you see here, how many operations would it take? First, second, first two, this is first, this is second, this is third, this is fourth, this is fifth, and this is sixth. Total 6 operations takes to convert this given string to 1, right? So here answer is 6. Okay. Okay, let me tell you some of the bits bits facts, right? Bits facts. Let's talk about some bits facts. So the fact is the first fact is, if you divide a number by 2, it means you are right shifting a bit, right? You are shifting a bit, right? You are right shifting a bit. What does it mean? If you see here, when we divide this 100, when I try to divide this 100, it becomes divided by 2, it becomes 0 1 1 1 0 0. What does it mean? This one right shifted by 1 bit to its right, right? This one shifted to right by 1. This, so same is opposite. So if you multiply if you multiply a number by 2, it means you are shifting a bit to its left, shifting a bit to its left, right? To its left, right? So this becomes, this is an 8, this is a representation of 8, this is representation of 8. So 8 divided by 2 is 4, whose binary representation is 0 1 1 0. If you see like this is true, right? So I we have a use of this right shifting by 2, because we need to divide by 2. Okay, the one thing again, the third fact, you know how to add a binary representation, right? If you see here 0 1 0 1 1 1 0, and if you want to add something like 1 here, something like 1 here, 1 here, it means we are adding on this number a 1. We want to add a number this by 1. So if I try to add a 1 in this binary representation, this 0 1 give me 1. Simple. This 0 1 will give me 1, right? This one, what does it give? This one, and this is 0 na, this is a binary representation of 1, so this is 0, this is 0, and we need to add a number by 1. So this 0 and this 1, it gives us 1. This 1 and 0 will give 1, so we will add 1. Again this will be give 1, so we will again add 1. Okay, again this will give us 1, so we will again add 1, right? uh it's something. Okay, we will align this, and we will align, yeah, this align. This is 0, so it will gives us 0. This will give us 0. So this is again 1, this will give us 1, and this is 0, so this will give us 0. So finally, if you see here, after adding 1, there is no effect, just only if 0 is present it becomes 1, right? But if something is like this given, 1 1 1, if instead of this 0 there is 1 present, what would be the answer? What would be the answer? So the answer would be, this 1 and plus 1 will give us not 2, because in binary representation there is only 0 and 1 bits, right? So this 1 and 1 bit gives us 10. So 10 means we can't, if you do summation like this, so it will give us 0 here, and 1 will carry forward to its left part, right? Because in binary representation we always traverse from left to right, from right to left. In binary representation, we traverse from right to left, right? Right, generally we traverse left to right, but in binary representation we traverse from right to left, right? So this is 1 1 and this is 0, and this 1 1 becomes 10, so the 0 is here and 1 will carry forward to its left part. Now this 1 and this 0 gives us 1, but here a carry forward is 1, so 1 1 again 10, so it should be 0 again here, and 1 will carry forward to here again, right? Now this 1 0 is 1, but 1 is also carried forward, so 1 plus 1 is 10 again, so this would be 0 and this would be 1 again, right? Now this 1 and 0 plus 0 is again 1, 0 plus 0 is 1, 0, and plus 1 is 1, so this would be 1. Now this would not be carried forward because it is 1 only, so this 1 0 is becomes 1, and this 0 becomes 0, right? So this would be the answer. So if you see what we observe here, if I sum the two, if I got two ones, it will gives a carry forward. If it's a carry 1 to its left, right? Otherwise no, nothing carry forward, right? So 1 plus 1 gives us 10, right? And 1 plus 0 gives us 1. So this is a binary representation, in only binary representation, because there is nothing like 2 in binary representation, right? So we will simply do like this. So this first and this third, we use this in this problem, because here we have two conditions which is divided by 2, and this is 1, and here this is 1101, right? And if you try to simply do this operations, so you need to see constants here. This is 500 length, it means it can go to 2 to the power 500, which is huge, right? Of course, so this should be not be occur, so we will need to operate on this length of this string. Okay, so we use first and third fact in this problem. So let's analyze how can we do this, right? So if you see here 1101, 1101, or take another example. What should I take? Let's take 01001101, right? Let's take this, right? So if I try to, okay, just take this example for sure that we have got our answer, right? 1101. So if I start with this one, this is okay. And one thing more, if there is, if there is if there is any uh, odd bit, if there is a shed bit at starting position, what does it mean? At the rightest bit, at the rightest bit, it means this here, this one. If there is a set bit, it means it's definitely an odd number, definitely an odd number. This you should remember, although it's not used in here, but this should be remembered. So these all facts should be remembered here, right? This is the fourth one. Of course, this is the fourth one. So if there is a set bit at the start position which is at 0th index here, from right to left, so it means it is a definitely an odd number, right? Definitely an odd number, right? You can apply any binary presentation and see, you can see that, right? So if see 1101, what we told, that if there is an odd number, I need to add one. So if I try to add one in this, so I just told you how to add one, how to add a number in binary presentation, right? So if I add one here, 001, what would become? It will become 11. It would become 11, which is 0 0, and it will carry forward 1 to its left part, right? Okay, this 0 plus 0 gives us 0, and this plus 1 is again 1, so this will give another one, right? Now this 101, here it will not forward anything, so there is nothing like this carry forward. Now this 1 1 will give us 1, so this will give us 1 again, and this 101 gives us 1 again, so it will give us 1 again. Now this becomes this, right? If you see, when you try to divide it by 2, this will gives us 7. 13 by 2 is 7. No, sorry, 6. Sorry, 6. This will gives us 6. uh, so this is an odd number now, this is an odd number, so I need to add a 1, so I add 1 here. So if I add 1, this should become, 14. This should become 14, right? So if I add 1 here, this should become 14. So 10 will give us 110 will give us 0, and this will become 0. This is 1. So this 0 1 2 3 is what? This is 8. This is 4 12. 12 plus 2 is 14, right? So this becomes 14, right? I think here I've okay, yeah, sure, this is 14, right? So this is how you add. So now this becomes 14, it means we have done an operation, so answer would be 1, right? Okay, now this becomes 14, it means it is an even number. It is an even number. So if you see here, if it is an even number, it means I just need to, if I divide it by 14 by 2, it will just shift it to the right, so it becomes 111. It just shifted. If 0 to if there is an even number, it will shift to its right part, so it becomes 7, right? If you again, so this is again odd, this is again odd, so I will add 1 again here. I will add again 1. So what does it become? It will become, 0. It will carry forward 1 again here, and this will become 110 again, right? This will become 001 again, and this will again carry forward a 1 here. This will again 10. This will again become 0, and this will again carry forward 1 here, and this will become 1, right? So from this to this, what does it become? If I add a plus 1 to here, plus 1 to here, what does it give? It will give us 8, and this is 8, right? So this one operation, this again one operation by 2, this is divided by 2, so this 1, and this again adding a 1, so this is again 1. Now why I'm showing this to you, I am showing is this to you because I was just try to make you observe something, right? If I again divide it by 2, what does it mean? It will right shift by 1, so it will becomes this right shift means this 1 will right shift to 1 here, so this becomes 4, right? Divided by 2, again one operation, again divided by 2 because it is an even, so it becomes 2, which is again one operation. Now, if I try to again divide it by 2, it becomes 1, which we definitely want. And after this becomes 6. So if you see here, this answer is 6 and we got here, and this binary representation we got. So if you see what we are doing here, what if you see here, that at the last position, at the last bit, if there is an 1, if there is an 1, it requires this one operations for adding, again one operations for shifting the 1. What does it mean? If you see here 1101, if you see here 1101, it requires one operation to make it even, and it requires another operation to make it to divide it by 2, because now, when it becomes even, you need to divide it by 2 to right shift the first part, because if you don't right shift, how does it becomes 1? Definitely, how does it becomes 1 if you don't right shift? So it means if there is 1 present, it means, what does it mean? It will require definitely a 2 operation. How can I say that? If you see here, this 1101, first it added 1, it becomes even. Now, for this even this bit, I need to right shift. For that, I need to divide it by 2. If I divide it by 2, this shift, this bit will be removed by this, right? Because this 0 is not anything, na. This we will see only from this starting bit, which is the set bit. So if there is a 1, and if I add 1, so if there is definitely the final answer is 1, so we require 2 operations to make it to make to remove the access of it. So this one will require 2 operations. Now this 2 operations becomes this, right? Now this is doesn't require any operation, this doesn't require any operation, this doesn't require any operation. It means it means that if 0 is present, the 0 is set, 0 is present, it requires only one operation. And what would be that? That would be divide by 2, right? And if 1 is present, then it requires two operations. Sorry, this will require one operation. If 0 is present, it on that would be divided by 2. But if 1 is present, it requires two operation. That is to add 1 to make it even, add 1, and then divide it by 2, right? So how we will check that? So I have just told you to try to add this, right? I have just told you to try to add the 1 is here. So if I see here 1101, so if I add 1 here, if I try to add 1 here, 1 here, so this is 1, right? This is 1, and this is 1 again. So this 1 and this 1 gives us what? This is this 1 and this 1 is gives us 2. What is that? That is an even number. That is an even number. So if it is an even number, it means it gives us 10. It gives us 10. Okay. Again, I'm telling something wrong, right? Okay. So this is a 1 and this is 1. It will gives us even number, right? So if you see here, this 1 here is definitely only single one. It means it is an odd, so it requires two operations here, right? It definitely requires two operations. So we will requires two operations for this one. When we go to 0, this has 0, it means okay, this is 1, so it requires two operations, right? So when you add 1 here, in this case, when you add 1 here, this carry forward a 1 to its right part. It means we also need to carry forward a 1 to its right part. So we will simply carry forward a 1 to its right part, right? Now this is removed because we have added 1 and divided by 2, so this is removed, right? So now this 0 part has carry forward 1, and this 1 plus 0 will again give me an odd number. Why? Because if you see, after this operation, this first operation and this second operation, right, the first operation and the second operation, this is the first and this is the second divided by 2, this is 14 by 2, this is the second operation, which becomes 7. So this is the first operation, and this is the second operation. After second operation, it becomes 111, which is again an odd, right? So if you see here, this 1 plus 0 is an odd, right? If it is an odd, it means I need to do two operations here. So I will again do a two operations here. So after these two operations, it will again gives a carry forward to this one, because I need to add one. Remember, I need to add one, because this is a, if this is an odd, this need to be add one, so this would carry forward a one. But for this, I have already divided it. So this is the third operation, this is the third operation, and after this divided by 2 is a fourth operation, this is the fourth operation, right? So this requires again 2, right? Now this becomes again 0, this now this 1 will carry forward to its left part. Now this 1 and this plus 1 gives us even, this 1 and plus 1 gives us even. It means, if you see here also, this 1 and this 1 plus gives us even, which is this one 0, right? This gives us even. It means we don't need to carry forward again, we don't need to carry forward again, because this will gives us even. So that would take only one operations, so we will apply only one operations. But this one will have carry only one, because when you add 1 to any of the numbers, if you add 1 to any of the numbers, it changes all the ones, adjacent ones, to 0, right? Changes all the adjacent 0. So it means the carry forward one will leads to change to this also, right? So we will not remove this carry forward one. So this one and one will also gives us even, so that will again take a one operations only, so that will be overall six operations, right? So if I try to take another example also, 11011 type this. So how we will forward? So first thing, if it is a 1, it means I require two operations, right? Now if I require two operations, this will carry forward a 1, because it is a 1, so I need to add a 1, so I need to take a carry forward to also 1. So this one and this one now becomes even. It means this one would become 0 on that part. So it requires only one operations. But this one will remain one. This carry forward will remain one. And uh, when we use this for, this will used for this 0, because if you remember, when you add 1 to any of this will leads to 0 to all consecutive ones, and after that, uh, at the right part, the first 0 becomes 1 here. So that's why I need to carry forward this 1 to its right part. Now this 1 plus 0 gives us odd number, right? So that will take again two operations, right? Now this 1 will forward to this here 1. Now this and this is an even number, right? So this will requires only one operations. Now this one will carry forward to this again, and this is again an even number, so this will require only one operation. Now this one will go to this, so this will gives us an odd number that require two operations. So again, when we go to this one will is even, so it requires only one operations. And finally, when we go to this require two operations, right? This requires two operations. Okay. One thing you need to see here, one need to you need to see what you need to see here, that the last part, this is the last part, right? If you see at the last part, if I add 2, because ultimately I need 1 at last, right? It means ultimately what would you form? This one would you form, right? So ultimately at last, this last point of any binary representation, there would be 1 required. So it means if I do operations on that, does it not become 0? If I again operations on that, it does it not become 0? Yes, it becomes 0 if I operation does the two operations on that. It means we don't require to make operations on the last part. It just depends on what operation would it becomes. It just depends on the carry forward, right? It just depends on the carry forward. That if the carry forward is 1, it means it will gives us 1, right? So doesn't need to add 1 on this. I just need to return answer plus this carry forward operations, right? This carry forward. Why? Because if you see in this previous example, this carry forward is again 1, right? So if I add this 1101, so it will gives us 1 again. But because I have add this 1 here, so this carry forward, if I add try this, so this will give me 7, right? Which is not correct. So if I remove this and just see the last part, which is 1, so that will give us 6, right? So it means I just need to see before the last part. It means I just need to see from the before part. Means from accepting the last bit, I will operate only on the except from the all the right bits excepting the last bit of left part, right? The leftest bit I will leave, and the operate only the rightest part. And after that I will just simply return answer plus carry. If the carry is 1, it means it has already won. Otherwise it will 0. If there is only 0 0 0 0, that will only condition is 0 0 0 0, right? So that's how this will be operate. So when will this carry will be 0? When it is an like this 1 0 0 1 0 0 0. The last bit is only the set bit, then only it will gives us the carry 0. Otherwise it will not give a carry 0, right? So this is how we will solve this. So ultimately what we are doing, we are we are just checking that after that, which at which position it is an odd or even number after adding carry. What is carry? This can be 0 and or 1. This can be 0 or 1. So if it is an even, it requires only one operations. It requires only one operation. And if it is 1, and if it is an odd, it required it requires only it requires two operations, right? And when will and till when we will apply these operations? Till the last second set bit, last the second bit, right? Either it is set or bit or not, we will apply last second. We will apply we will check this till the last second position from left, uh, from right last, right? From right last second position, right? From left it will be the first position. From left it will be the first position. First position. So we will apply these operations, and after that we will check that if a carry forward is 1 has 1, it will return answer plus 1. Otherwise it will return answer plus 0. So basically it will return only answer plus carry, right? This would be the answer. Let's try to implement this. I think you will be better understand on that part. right? So let's try to implement all thing is committed commented. Okay, this left. The first thing is what we do. We will we will traverse from the last from the right to left, right? We will traverse from right to left till where greater than 0, because the last the we have just told, just see that why we need to move till the last second position, because ultimately we need to return 1, so the last position has 1 or not, it depends on the carry forward, which is 1 or not, right? Simply. So what I need to do, I need to just make an answer a carry which will initialize to 0 initially. So now what we see, if this si has 0 or 1, so I need to convert this to 0 or 1. For that, what I need to do, I need to typecast this. So si minus 0 will give us 1 or 0 plus this carry, right? If this whole as number is odd number, if it is an odd number, right? If this is an odd number, it means it requires two operations. It means I need to add a 2, and it also give a carry of 1, right? It also gives a carry of 1, and it requires two operations. Otherwise, if it is an even number, it will just requires one operation, right? It just requires one operation, right? So this is how this whole question will be based on this 2 and 1 and some of the bits properties which I have told you. This bits fact, you should remember this bit facts, because this will be used in many questions, this bit facts. So this is how we do, and just we need to return this answer. Let's try to run this. uh, okay, something wrong. Okay, I need to also add a carry at last, because this depends on carry 1, that the last part would be 1 or not. So if it is 1, the carry will be 1, otherwise it will give 0, right? So the I need to add a carry on this. Yeah, we have successfully passed the sample cases. Let's try to submit it. Yeah, we have passed it. So why we are carrying adding the carry? If you observe here, I just told you that this carry would ultimately result to the last part of 1, which we ultimately require. We need to make it 1. So this carry will, if this carry has a 1, it means it has it need to do a 1 operations on the last part to make it 1. Otherwise it don't need to do anything, right? That's the only it represent. Hope you liked it. I think that's a bit confusing, because thinking in bits is a bit difficult part, right? Thinking in bits is a bit difficult part. So I think you should take a pen and paper and do all these things by your own. You will get a better understanding, right? Take pen and paper and write it your own. All these things which I have told you, you will understand better, right? You will understand better. So what will the time and the space complexity would be? So it is not. I think you have already analyzed it. Again, for the purpose of completion, I told you that this is O of n, of course. So that would be O of n, and I haven't taken any extra spaces. So that would be O of 1. Right. So yeah, this is how we will solve this question. Thank you so much. Bye bye.